Thank you everyone for joining this evening. I think, as George said, let's make every minute count. I'm going to make my talk very, very fast, hopefully as fast as your CI after this talk. Let me first start with a very quick question. I don't want you to be prepared. So I'm just going to put a timer when I ask a question. What is the capital of Australia?
Melbourne. Canberra.
Okay, so that was 2 seconds. What's the capital of New Zealand?
Wellington.
Okay, so 3 seconds. All right, that's all. Story time. The reason I'm doing this entire talk, is like a couple of, I'm just going to give a bit of context. I think the context here is the king because it's the only important thing. So it's a Thursday. We're in a company. This repo is about like where 20 people producing PRs to this repo every single day, minimum like 10, 20 PRs every single day. And the RC is about to be created, like was created on Friday, and now we have 1 week left to fix all the problems. And the RC cut is tomorrow, Friday. So let's imagine this, tomorrow, Friday, 5 p.m. The final release from our new RC is going to be released to all the users. And today is Thursday, and the time is around 1 p.m. And obviously, my PM comes to me and says, well, there is a very urgent bug. It's the most urgent thing in the existence right now. So let's fix it. We need to get it fixed. And came up with all the excuses, but there was nothing to me to do apart from let's just fix it. So it seems fixable. I said, let me try to give it a try. And then about 2 hours and a half, I figured out the fix. And obviously now I need to make it, to make the reviewers happy about it. So it took a bit of time to create the PR and to get it all within like the GitHub pipeline. So by 4 p.m. the team has approved, and I created the PR. But there was one thing that I usually not always look at, but it's mainly because, you know, like when you have anxiety from something, you don't want to look at it. It's because of RCI takes a lot. So I didn't want to look at it. I was just hopeful that somehow magically it's going to run and quickly finish doing what it's doing. It's doing a lot of things. It's doing, obviously, running the test, pub analyze. We have a lot of packages, like I think almost 50 packages. I don't even know the number anymore. There's a lot of packages, and the test files are also a lot of them. So you can imagine. And then there is also the bottleneck, the main one, which was the coverage, because every time our CI runs, we need to calculate the coverage against all the files to decide whether you pass the coverage or not. So it's not just running the test or doing lints or analyzers. We have a couple of custom lints here and there. That explains the reason why we have 30 to 40 minutes. It depends on how hot the device is and how warm it is and ready for everything. So by 4 p.m. I created the PR and got the approval, but somehow by 4:30, it's the time it took for the CI to get back to me, he says, well, this thing has failed because the coverage is about 39 and needs to be 45, so you need to fix it. I was like, need to do something quick. I went to Claude, obviously, asked it, can you do the test? It did the tests magically, and I should definitely clicked push as soon as it finished doing all the tests. It did the test and it pushed the fix, and now I'm just waiting. So I told the RC team, because they need to create the RC by that time, so they can go ahead with their days and leave the office and not keep waiting for me. And then for 5:30, I got back the results, and it was bad. That, yeah, Claude actually fixed like the tests that were there, but it did it in a way that created some new files, so the coverage is now below the amount again. So it didn't just add new tests, it added new code. So the only way this was done is I said, well, there's no way to do it on Thursday. I'm going to do it on Friday, carefully, after a few other iterations, and the PM is going to be able to test it on Monday. That was the sad story, but I didn't forget it. From that moment, every single minute I've got was for me to figure out how can I improve our CI. So this is the demo project I created. So to show you like all the optimizations. So it's like a public, it's not public, is it? I forgot. Let me make it public right now. I understand the risks, yeah. Wow, I just realized.
What did you realise?
Yeah, the tests are not running. That's what I realized. Okay, so this is the project that I have here for you. It's like I just created like a very sample project to reassemble like a huge project, but this is a very minimized version that I can obviously run. I don't want to show you like a bad CI that runs for 30 minutes in this talk. I wouldn't be able to do anything. I wouldn't be able to do optimizations or anything. So I did the minimified version where if I go to the terminal right now and is this actually, let me just run the tests here locally first. Let's say the current way of running the test, which is the base version. Live coding. You. Okay. Again, let me do this. This is good stuff. That's exactly how I ended up in the situation last time. But yeah, so this is a very minimized version of the project. So it doesn't have, I think it has about, how many tests? I think 500 tests. Like the amount of modules is very minimal, but it's still like a couple of modules. I think about 5 modules. As you can see, the dependencies are very small, but somehow the tests are going to take a while. So I'm not going to keep showing the tests until they are done. I'm just going to go back to the slides. This is the structure. It's like app and core and payments. These are the packages. And once the tests are done, I will get back to this slide. There are about 239 files. This is very minimal. For any other company, you will have like 10 times this. Yeah, for any other medium-sized, bigger company, you will have 10 times, 100 times these numbers. These are rookie numbers, 200 files, 4 packages in total time. And with this, I think, even with this basic setup, my tests are still running. And I can't do anything until they're done. Okay, it says 300. I might have added a few more, so the slides are not up to date. But yeah, our project was, let's say, 10 times this. So we created the minified version just to demonstrate all the problems that were there and all the optimizations that was able to do to minify it. Okay, so we got okay, doing it one package by one package. That was only one package. Success. Okay. Imagine doing this and it's taking 10 times longer. Wow. So what this script here is doing is obviously doing the normal stuff, linting, formatting, and then pub.get, and obviously running the tests with coverage. And obviously there is a big difference when you run the tests with coverage versus without coverage. Like the main bottleneck starts to show up when you're doing it with coverage. So hopefully this thing is going to be done. Moment of silence.
You got a future dot wait in there.
You got it?
Yeah.
You got it? I did it? Yeah, for sure. Otherwise, I cannot create an entire project as slow as this in a couple of days. In order to create a slow infrastructure, you need years of hard engineering to make those mistakes. All right. Let's skip to the next slide and I will come back to it. So these were the results. The results were that after these fixes, we're going to have all of these. I will demonstrate all of the improvements. One is, as Tom mentioned, is that there were bad tests, like whether it's future delayed or like you're actually doing, for example, the real call to HTTP call instead of doing like a mock version of it, or you're doing a lot of excessive pumps in the widget tests. So all of these things, let's consider them as one thing, which is that you have bad tests and you need to have some sort of a way to tell you that, hey, somebody pushed a bad test that a test that takes longer than, let's say, the minimum that we have set in our repository, which is you cannot, if the test takes longer than 2 seconds, then it's already a bad test. Let's just have some sort of a rule to keep everyone aligned. Then obviously there is parallel. The tests that I'm running in the background are not running in parallel, and that was the same case for us. I think the main reason somebody doesn't write parallel packages, or if you go to any repo and you try to do parallel and then you stumble upon one thing. I'm not sure if and if you have seen it, is if you go to a repo and then you try to run the tests in parallel and then they are broken, it's mainly because the tests are reliant on singletons, so you kind of have like a stale state. You can, like, the tests only run in one way, which is sequential. So that's obviously not the parallelism problem. It's obviously, again, the bad test. Like, your test needs to run in isolation. It doesn't need another test to run before it, and all of those problems. So let's call these kinds of problems bad coders. And then we have another one, which is a test bundler. This is something I'm not sure how many of you have had to face before this issue. It's mainly with coverage, but I created a tool to help you reuse the same solution I've had there. And then obviously there is the cache, and then selective, like when, especially on the CI, you see what changed, and then you decide what you will run the test on, especially if you have a good a good way of modularizing your architecture, so that you don't have to rewrite all the, rerun the tests in all the packages. I think the tests are done. No, not really. Okay, so let's go through these one by one. Well, it's kind of doesn't make sense. I chose this device. I was running them on an M4 Max. I did not run them on this. I brought this one on purpose because it's slower, and I did not think it's actually going to be like proving my point so beautifully. Like, this is amazing, but not really. So the tests are going to take a while, so we will wait for them. Yeah, so the first thing I found out after analyzing the tests with like a bit more details, because I decided I have to fix this problem. The main like problems were there, as Tom mentioned, is that there were actual delay. Like, you go to this test and somebody couldn't figure out a way to make this test pass, so they added future delayed, and they make like, oh, let's give it three seconds. It's just a random magical number. It's the only one that fixed the test. So you could find those, but you wouldn't be able to spot them if everyone is like writing 10 times the code thanks to AI. You wouldn't be able to spot them with your eyes unless you have an automated way. So that's what the solution is to have some sort of a guard against the test. So once all the tests are run, you collect the time that it took for each of them, and then you have a baseline. You have one test. One of these tests took longer than it should. It should give it as a comment in GitHub telling the PR creator, hey, you either fix this right now or you do it later. I don't want it to be blocking like the PR creation or the merge of the PR, but it's just to let the developer know that they have done something that messed up. The other one I found is the setups, especially in widget tests. I have seen this like a lot, is to warm up or it's not specifically future delayed. I think it was more like future, but doing an actual work. So future delayed here is just an example, but it is just an actual future in the setup, which means if it isn't the setup, it means it will run on every single one of the tests in that group. So the amount that we have to wait is always accelerated. Then there were some really huge test files. I think those were not the biggest problem, but somehow they caused the test concurrency not to pick them all, because they have to do with one file after another, and this file is just one huge file. The other one is pumping. This is mainly for when you have animations. So it's like you're trying to wait, and then you instead of doing like just a simple pump and wait, you're like doing a loop of pumping. There were not a lot of cases of this. I think I found just one or two. I don't know why, like when I found them, I couldn't figure out exactly what was the reason they were added. I added pump and wait, and it didn't work, so I just removed the tests and I was fixing it. There was some actual tests where they were doing the async job, like a real, like writing to the database instead of actually mocking that. So those were the bad patterns. I think there is the list grows bigger. Oh wait, finally, 6 minutes. Okay, so that was the baseline. At least we initiated the baseline. This is the baseline it took for our very sample dummy project to run all the tests. So we will get back to it after we do the fixes. So the first set of fixes, as I said, is to look at all these reasons and come up with a way to automate picking up these bad test patterns. The results, obviously here, I was using GitHub Actions because that's where the time matters. Here on my device, it was 6 minutes. On GitHub, it was about 8 minutes because it's not, even this device is slow. The one in GitHub Actions, they don't provide you with the latest M5, that's for sure. So you get a slower device, you get no concurrency whatsoever. It's a single core one. Here you can see, like, for every one of these items they provide here, I will show you like the GitHub action run for it. So this one took 8 minutes and it was like very basic. I was just doing run sequential. The same one I did here locally. It just took longer because obviously it's a different device. If I go back here, the second one after fixing the bad tests is how long it took. Well, this is how long it took. Not found. Well, ignore. Parallelism. This one, yeah, this one is for sure is the one that gave me the biggest update, or the most obvious way to make anything faster is obviously to parallelize things. So instead of doing the tests per package, or like the tests one package after the other, do all the packages all at the same time. The main problem I faced with this one is we were using, like for these tests, we were using something called Tecton, I think, is not GitHub Actions. So I wasn't able to share the pub.get. So the problem was, how can I share the results of pub.get? Because our pub.get was taking 2 minutes. Our packages, when you combine them all, because you cannot run the tests unless you have done pub.get and you've got all your packages. You cannot run the test otherwise. So my problem was, how can I share it? The answer was, obviously it's in the repo. It was somehow like figuring out how to cache it. And then this is only a problem in the CI, because the first thing you come up with is, I have 5 packages, I'm going to run pub.get and then run the test on each one of them. So here what you have is wasted time. It's just in the pub.get. If the time that it takes to do pub.get is 2 minutes, you're doing 2 minutes here in every single package. So the parallel thing will work better once you have done the sharing of the results of pub.get. It's in the repo there somewhere how you can share it. The result here was obviously better. So what I'm doing here is the baseline. Remember, the baseline was 8 minutes, so I'm always trying these fixes in isolations. I'm getting the baseline and then I'm trying only these fixes and see how they affect the final result. So with parallelism, it was, let's say, 34%. Obviously depends on the device, but 34% was the result from GitHub Actions, from running it in GitHub Actions with its limited resources. The final one, let me see. Yeah, this one was very interesting. So this one is when we run the tests with coverage in Flutter, every time or for every file, we are doing an RPC call. That RPC call has always a cold start, which is the same, about 300 milliseconds. It can be like faster on a better device, let's say, on a much faster device. But this time you multiply it. So the more files you have, the longer, the linearly this amount is going to go. So for example, here in our simple project, we had about 239 files, and that produced literally 72 seconds being lost from the entire operation. And then the problem, as you can see, if I have 2,000 files, it's 700 seconds, and that adds up very, very quickly. So the solution to this was something where you will create one file, and you mention all the other files that you have in the test. For example, I have in one package 20 test files. I create only one file and I call it all tests, and in that file I mention or reference all the other tests, let's say, and then I only run the tests on that file. So that one removed obviously the cold start. There's only one cold start versus 10. So that was the biggest jump. The problem with this is that you might need to adjust some of your widget tests to do cleanup. I have done it here in a much better way. If I can find the script, you can actually just go. I made it as a package because I'm pretty sure it's going to be useful to any other. I called it test bundler. So the way it works is instead of running just Flutter test, you just run this one here. I provided it as a reusable package here in this public repo. Yeah, it's public. You run this command, whatever, and then the result is it's going to go through all of your test file in all of your projects, and it's going to create one big file based on, like we say, one big file. That's obviously by your choice. If you want multiple files, you can say. So here, for example, I said shards 4. It will create 4 files for me, and all of these 4 files are going to reference all the tests. So it will try to see like what is the best way to divide all of these test files into these folders. And that was magical. I think that was another speed up that I could not figure out where it could, like that it could come or it would be easy. The problem with doing that is I was trying to do it manually. It was kind of a manual job that I did not want to do, but I created like a script that goes through all the files and decide which files is going to go there. So the result with that, where is it? Is it this one? So yeah, it was 4 seconds, but here in the slide it's comparing it to the parallelism. It's not comparing it to the 8 one. So the 4 minutes, let's say, is an improvement from the 8 minutes, not from the 4 minutes here, because I did not build it. I did not compare it to the base. I compared it to the after the parallelism. So the jump doesn't seem that high because we have already done improvements. So the goal is obviously to combine them all at the end. So here, this is just for you, obviously, all to try whenever you get a chance with the repo to see the difference on your end. These were obviously some other, I think I mentioned the first one is running pub.get and pub.analyze per module or per CI job. This is only a problem for you if you are trying to make every minute count. So if you have 2 minutes, you don't want to duplicate that 2 minutes every single time you have parallelism going on. This one is, I wanted to bring it mainly because of the costs. It's not about speed, it's mostly about the cost. What we had in our CI is that with every single commit being pushed, you have a Dart, like a full iOS and full Android build to make sure that the build has not been broken. And that was obviously expensive, especially the iOS one. It was costing us like easily more than £1,000 each month in terms of cost. And you wouldn't want to remove this, because if you remove this, you kind of break the whole CI/CD thing. So the solution was to look for changes in the diff change script, to look for any changes that touch either Android. If there were Android changes, let's do the rebuild. If there were pubspec.log changes, let's do the rebuild. Anything that would cause the Android build to be changed, you would rebuild. Same for iOS. So this one is obviously is not like making the whole thing in itself faster. It's just making it waste less time if there are no changes. Most of the PR, and then we did like a quick analysis of most of the PR. Most of the PRs don't touch pub.get. You don't add packages every single day. You don't change this Android or iOS settings every single day. So this is what I put in my performance review, by the way. Is like, I took you from here to here. But yeah, it really helps, especially when you bring it to the management, the numbers. It's like, last month it was this month it was this. So I definitely recommend you do this if you haven't already. Okay, I think it's time for me to run the latest one, which is when I am doing all of them. Notes. So these are the same tests. It's just using a combination of all the fixed test, obviously, first one, and then the second one is parallelization. So even this device, I don't know, it has only 4 cores. It still is going to be able to do some parallelism. And then the test bundler, and we can try it. As you can see, it has generated the shard files. It has generated 1 file per, let's say, per module. And now it's running all the tests locally. Hopefully, this one is going to work. If it works, I'll finish. Oh, it did. So, well, I think that was a bigger improvement than I expected, but yeah. So this is the first thing that comes to your mind. Did it actually run the test? Because this is too fast. And that was the reaction of my colleagues when we had it like going from 40 to 30 minutes. They were like, the first thing I've seen in Slack was like, I think the tests are not running. I had to prove them that the tests are running because, yeah, if you go like by 10x, it kind of feels like the tests are not running. But that's why the repo is public. You can give it a try and you see for yourself all these improvements. This is not related to the test itself. Is the point I mentioned about the diff coverage. Because the main reason our CI is slow is because we have to do the diff coverage thing. So if we did not have to do coverage collection, I think it would have been obviously way faster. But we needed to have like code coverage collection in the CI itself so that people don't just merge PRs without like covering it with enough tests. But like the main reason we did that is because we had like low coverage and we wanted to increase it. So there is no other way other than enforcing it. So yeah, I think these were the final results. It was from this project, when I tested it, I ran the benchmarks on using GitHub Actions. I'm still on the free tier, so it's like good I didn't go beyond that. The initial one is 8 minutes, and all of these are in isolation. So I took the baseline and then I fixed the test. It took 5 minutes. I took the baseline and then I did it in parallel and it took 4 minutes. Obviously, when you combine all of them, it's not gonna just magically add up like magic. Obviously, there's still some constraints, but like here, for example, this one is like about the diff coverage. It was mostly about selective tests, but I did not want to show the result with selective tests because I wanted to run all the tests. Because obviously, if I made only one change to one test, it's going to run way faster. So all combined, you can think of it as the text being fixed, the test being fixed, and the parallelism on like being enabled, and then you have the test bundler on top. So that's the final result. It's too many slides. I think it's just one question. What is the capital of New Zealand?
Wellington.
Okay, so you guys at least are faster if your CI isn't. So this is how cache work. If you remember the answer, you can always do it again faster. If you have any questions, let me know. But that's all I had today. Thank you.
So any questions?
3, 2, 1, go. Fast.
Paul has a question.
Yeah, could you just talk a little bit about the isolate optimization? So is that 300 millisecond startup something that's inside Dart?
Yeah.
Something that's happening.
It's a Dart it's a Dart issue. Like there is an open issue for it, and that was the hack like of creating one file that combines all of them. I might not have been completely honest with the downside because there was one downside, which is the memory, because like we started obviously observing like sometimes our containers running out of memory, like it's running the test and boom, suddenly it's like it dies and we have no queries, like no errors. It's just there were no more memory. So that was the downside of it. That's the main reason obviously the Dart team doesn't make it as like the default option, because the more files you have in one file, the more memory it's going to consume. So it's like a known issue, but it's more like a let's say a calculated downside from their side, because for them, like they want something scalable. This is not scalable, but the reason it's scalable is because I know all of my projects. I know how many projects is like I've done the calculations. I have given it enough memory. It's probably for the first week there was no failures, and then the more tests started to come in. So with more tests, the containers started to break. What I did was like, all right, let me just increase the memory. I think for about 6 months we have seen it like die, the container die because of this issue for like 4 times maximum, but we knew like this is the reason why it dies. But I don't know, I don't think if I have mentioned the GitHub issue, but there's a GitHub issue that's open that says, yeah, if this is the workaround and this is the downside if you are happy to live with it.
Okay, cool. No, thanks. I'll check that out.
Yeah, it's a cool trick for sure, 100%. It's the coolest trick I've found.
It just seemed like a long time for an isolate to start. So
I think,
I'll check it out.
yeah, for sure.
Have you any experience with any other CI/CD platforms other than GitHub?
Well, CodeMagic is faster, but we don't use it. CodeMagic is faster by default is because they made it for Flutter, and they have like it's obviously just like different kind of scaling. They have the latest devices. They have the M2s, the M4s, while GitHub Action is still at M1. Like this is the one that they can use. And the worst is that ours, as like we use something called Tecton, which uses some AWS devices, and I think they're using Intel.
So besides the tests that you're running, these are unit tests, are they?
Unit and widget and widget. I think I will like there was another completely different phase in MATLAB where I was optimizing our Maestro tests. That one is worthy of a talk, but this is only for widget, unit, and like when I say integration, not like integration that runs the app, but more like complicated widget tests.
What about patrol tests?
No, that's we use Maestro for that. So we don't use we don't use like patrol. We just use Maestro, and that one is obviously a different kind of problem on its own.
Anybody else got any more questions? All right. Well, thank you very much, Raouf.
Thank you.
Right. So